Hi, welcome back to my channel Easy to Learn. So this video is about the design consideration behind microwave power amplifier and its related multiple choice question. Now see this diagram. This is one of the product of microwave power amplifier, and inside it consists of a lot of active as well as passive elements like filter and amplifier. But basically this microwave power amplifier is a large signal amplifier category, but especially utilized in the final stage of radar and radio transmitter to increase the signal strength. And these are the frequency ranges where this microwave power amplifier is especially utilized from L band to W band, that is from 1 GHz frequency to 110 GHz frequency range. Basically there are two type of model. One is solid state model, another one is tube type microwave power amplifier model. And this one it shows as solid state microwave power amplifier model in the radio frequency range. By using these two type, we will get an increased power from milliwatt to more than 3000 watt power. So such a high power device, when they are manufacturing, they have to consider a lot of factors, but these are the very important factors: gain, efficiency, intermodulation, distortion, thermal effects, and frequency range. And apart from this, noise figure also an important one. This gain, it represents how much the signal strength is increased from input to output, and the formula is 10 log of P out divided by P. This efficiency, what it represents? It represents how much useful power we get from the output according to the input given. So why they are considering these two very important factor means, suppose if we are concentrating on the gain increment, then we will get some reduction in the gain efficiency. Or if we are concentrating on efficiency, then we will get some reduction in the gain. So basically they will go for some balance between these two, gain as well as efficiency. Now the third factor, this intermodulation distortion. When multiple signals are combined and transfer as an input of this microwave power amplifier. So what will happen inside? Because of this mixing of signal create intermodulation distortion. So what is this intermodulation distortion means? The frequency range of this distortion signal is very close to the desired signal. So suppose if you are utilizing some filter for discarding this distortion frequency, then we will get some reduction in the original signal also. So this is also an important one. Now the fourth one, thermal effect. Because this is an energy boosting device, so when energy is increased, automatically thermal effect also increase. But due to this, what is going to happen inside, the power dissipation problem will arise. So this is also another one, but basically they will go for some compensation circuit for solving this thermal effect problems. Now the next one is the frequency range. Frequency range means these are all linear device up to some frequency range, but after that frequency range, this active power amplifier device, it start to produce a decrease in gain. So that frequency range also important factor. Now these are the classes of power amplifier: class A, class B, class AB, class C, and class D to T amplifiers nowadays are there. Now this class D to T amplifiers, this is called as pulse switching type model, and this is especially utilized in the digital circuit. And this class A to C type models are called as linear conduction angle type, and the another name also called as analog power amplifier. But this microwave power amplifier range, this pulse switching type model is not utilized. Upon multiple choice question la, whether this class D to T amplifiers are suited for this gigahertz frequency range amplification, means you have to click the option false. Now coming to this class A amplifier, this is the conduction of angle of this class A amplifier, that is 360 degree. That means the switching device which is going to produce this output, that has to switch on for the entire cycle. So due to that, the overall efficiency is decreased, but it can produce linear output, and the efficiency is around 25 to 50% only. But when you are going for this class B amplifier, the conduction angle is only 180 degrees. That means the switching device only on for a 1/2 cycle. Therefore, that means a half of the cycle. Therefore, the efficiency is improved around 78.5%. But if you need full cycle, we have to utilize 2 transistors in the complementary push-pull configuration. So this class B amplifier, what it will produce? A distortion in the output. So this is one of the disadvantages in class B amplifier. But if anyone concentrating on high efficiency, then they can choose this class B type model. Now coming to this class AB type, no, this is especially designed for overcome the problem in class A as well as class B. So the conduction angle is greater than 180 degree but less than 360 degree. But the efficiency what we are getting, no, 78.5% like class B amplifier, but the intermodulation distortion problem is solved. So according to this advantage, this class AB type is especially utilized in the microwave power amplifier design. Now coming to this class C amplifier, no, the conduction angle is less than 180 degree. So the design is the switching device has to switch on for a small period. So due to that, the efficiency level is 95% to 99%. But due to that less switching on and off period, it create a lot of distortion compared to the class B type. So because of this lot of distortion, this class C type is not utilized in the microwave power amplifier design. Now this is one of the table you have to remember for attending the multiple choice question: conduction angle, efficiency, operating point, and distortion of class A, class B, and class AB and class C type. Now these are the important formula you have to remember. First one is the drain efficiency or collector efficiency. Why this provide drain and collector? No, if you are utilizing a PET device means then drain efficiency. If you are utilizing BJT means then collector efficiency. The formula is P out divided by PDC. P out represent output power, PDC represent DC input power given. Now the next formula is power added efficiency. This power added efficiency, what it represent? No, what is the contribution of this DC input power for generating useful output power? So basically this power added efficiency is an important parameter for analyzing the capacity of that particular amplifier, and the formula is P out minus P in divided by PDC, which is equal to 1 minus 1 by G into P out divided by PDC, where G represent gain, and that is equal to 1 minus 1 by G into eta. So this will give the relation between the collector or drain efficiency with the power added efficiency. Now the third formula is compressed gain G1. This compressed gain G1, what it represent? No, I told you, no, up to some frequency range this power amplifier work as a linear device. After that frequency range you will get the reduction in the gain. So which frequency we are getting reduction in the gain? No, that is called compression gain at 1 decibel point. So the formula is G0 decibel minus 1, where G0 represent linear power gain. Now based on this, these are the multiple choice question. Question number 1: DAS are used in the final stages of radar and radio transmitter to increase the radiator power level. The options are power amplifier, oscillator, transistor, attenuator. For radar and radio transmitter, power amplifier is especially utilized, so the answer is power amplifier. Now the next question: important factors to be considered for power amplifier designs are efficiency, gain, thermal effect, all of them mentioned. The answer is of course all of them mentioned. Now the third question: amplifier efficiency is the ratio of RF output power to the DC input power. This parameter determines the performance of an amplifier. The options are true and false. Of course, efficiency is represented output power divided by DC input power. Therefore the answer is true. Now the fourth question: the gain of power amplifier DAS with the increase in operating frequency. The options are increases, decreases, increase efficiently, decreases exponentially, and I told you, no, gain will be increases up to some frequency range. When we are increasing beyond that frequency range, the gain start to decreases. Therefore the answer is decreases. Now the fifth question: the amplifiers are linear circuit where the transistor is biased to conduct over the entire range of the input signal cycle. The options are class A amplifier, class B amplifier, class C amplifier, and none of them mentioned. In the question they provided linear circuit and the conduction angle is whole input signal cycle. That means 360 degree. For 360 degree the answer is class A amplifier. Now the sixth question: a class B amplifier consists of DAS transistor in order to conduct the input signal over the entire cycle. And these are the option 1, 2, 4 and 6. Question they ask class B amplifier for conducting entire cycle. Class B வந்து 180 degree தான் conduct பண்ணும். For entire cycle conduct பண்ணனும்னா we need 2 transistor in the complementary push-pull configuration. Now question number 7: power amplifier in the increasing order of efficiency is class A, B, C, and class C, A, B, and class B, A, C, and the efficiency of all the three amplifiers is the same. Increasing order la கேட்டிருக்காங்க class A ஓடது 25 to 50%, class B ஓடது 78.5%, and class C 95%. So for increasing order, the answer is option A. Now the 8th question, the behavior of the transistor in the power amplifier is unpredictable at all input signal levels. The options are true and false. So transistor power amplifier oda behavior எல்லா இன்புட்டுக்குமே unpredictable அப்படின்னு கொடுத்திருக்காங்க. It's not like that. It is predictable up to some range. So the answer is false. Now the 9th question, if the output power of an amplifier is 10 volt and the input power supplied to the amplifier is 0.229 volt, given that the DC voltage used is 38.5 volt, the efficiency of the power amplifier is, actually these are the option and we are getting the answer is 25%. I will show you, but before that, now see the question, given data is what? Output power, input power, and the DC voltage. So the efficiency they asked us power added efficiency, and the formula is P out minus P in divided by PDC into 100 because of representing in percentage. So when you are substituting the value, you will get 25.37%, and that is equal to 25%. Now the 10th question, if your power amplifier has an output power of 10 volt and an amplifier gain of 16.4 decibel, then the input drive power is, actually these are the options, and the answer is 229 milliwatt. See, in the question they provided gain and output power, but they are asking the input drive power gain. Actually this is the formula for gain, 10 log of P out divided by P in. So once you substitute this value, you have to take anti-log. So 43.65 equal to 10 divided by P in. Therefore P in equal to 229 milliwatt. And that's all about this microwave power amplifier. Thank you so much for watching this video. If you like my video, kindly subscribe my channel.